Hi, geometry students. It's Miss Kaiser here teaching 11.5 volumes of prisms and cylinders. So here we go. I hope you guys are all doing well. Miss you. Wish we could do these videos all together with the other two teachers, but you're stuck with just me today. All right, a volume of a prism. So the volume of a solid is the number of cubic units contained in its interior. So the volume is you fill up, like you're filling up a cube. Volume is measured in cubic units, such as a cubic centimeter, and you write it as centimeters cubed. Okay? If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So even though one of these cubes in the picture looks slanted, as long as the area of the cross section is the same all the way throughout and the height is the same, then it's got the same volume. The prism at the right have equal heights and equal cross section areas of the base, which we use capital B, at every level, and therefore have the same volume. Okay, so the volume of a prism. So the volume of a prism is the base area times the height. And the base area is going to vary. The formulas for the base area, which we use capital B here, is going to vary depending on what the shape of the base is. If it's a rectangle, it's the area of a rectangle. If it's a trapezoid, it's the area of a trapezoid. If it's a square, it's the area of a square. A triangle, it's the area of a triangle. Times the height of the prism. So capital B means base area. Lowercase b means the height of the actual base. All right, so here we are. Now, we've got to determine where the base is of this prism. So when you have a prism, all of the sides are rectangles. So if that's the case, what's facing forward to us is a trapezoid. So that must be the base. So the idea here is this prism is tipped over on one of its sides and the base is facing us. So the base is a trapezoid. So we're going to find the volume by finding the area of that trapezoid and then the height of the prism. And the height of the prism is actually 4.2 meters, not 2.5, because it's tipped over on its side. So the base area of a trapezoid is 1/2 height of the trapezoid. So when you're looking at the trapezoid, the height of the trapezoid is 2.5, just not the height of the entire prism. So 1/2, 2.5, times base 1 length and base 2 length of that trapezoid. So just look at the trapezoid now. And the bottom base is 5.6 and the top is 4.4. So we're going to calculate all of that. So I'm going to add those decimals together and then multiply 1/2 times 2.5 times 10. So that's my base area. So then my volume is the height of the prism, which is 4.2, times the base area, which is 12.5. And then it's in meters, so we have to say meters cubed. All right, excellent. Same thing in B. It is not sitting on its base is facing us. Its base is a right triangle. The height of the prism is 3 centimeters. But the triangle facing us, we're going to find the area of that, and that's 1/2 base times height, because it's an area of a triangle. And the base of that triangle is 5 centimeters, and the height of that triangle is 8 centimeters. And then the height of the prism is 3, because if you knock it over, you'll see. If you knock it over onto the triangle, you'll see that the height is 3 centimeters. So our base area is 20 centimeters squared. And so our volume is 20 times your 3. So this is centimeters cubed. Okay, so if you have any questions, please let me know. I'll do a Zoom session with you guys. All right, volume of a cylinder. Same idea. It's the base area times the height, but all cylinders have circle bases, and the area of a circle is pi r squared. So it's just height times pi r squared, because our capital B is a circle, which is pi r squared. And Cavalier's principle works the same. If the base area is the same and the height is the same, then the volume of the two figures are the same. So capital B in this case is pi r squared always, because a cylinder is always, the base is a circle. So again, this cylinder is lying on its side. So the height of the cylinder is 9.1 meters. So your volume is going to be the area of the circle, which is 5 squared times pi, which is 25 pi, times your 9.4. Now, it gets us to exact value. That's the exact value answer. Leaving pi in the answer. Okay? This would be 2 decimal place answer. You would take your calculator and multiply 227.5 times pi. So make sure you look on Big Ideas and see which way they want you to answer the question, with pi in your answer or multiply pi out on your calculator. All right, B is an oblique cylinder. This oblique cylinder tells you the height. You have to get the height by going outside the cylinder. And that's 22 feet. This one is lying on its base. So the area of the circle is 49 pi, because 7 squared is 49. And then the height is 22. And so that's the exact answer with pi in it. And this is a decimal, 2 decimal place nearest hundredth answer. And that's taking the calculator and using my pi button. Make sure you figure out how it wants you to answer the problem. And I know on Big Ideas, there'll be a pi button on the keyboard there. Okay, I think you guys got this. Density formula. So density is the amount of matter that an object has in a given unit of volume. So the density of an object is calculated by dividing its mass by its volume. That is density. Different materials have different densities. So density can be used to distinguish between materials that look similar. For example, table salt and sugar look alike. However, table salt has a density of 2.16 grams per cubic centimeter, while sugar has a density of 1.58 grams per cubic centimeter. So it might look the same, but the density is greater in the salt. So remember, density is mass over volume. So in example 4, the density of water is 1,000 kilograms per cubic meter. Find the mass of 1 cubic foot of water. And know that 1 foot equals 0.3048 meters. So density equals mass over volume. And it tells you that the density is 1,000 kilograms. And it says find the mass of 1 cubic foot of water. So what you want to do is you want to cube in meters. So you're going to cube it. And then you're going to cross multiply there. And use your calculator. And that's how many kilograms. Okay? We needed to move to the metric system from feet because we're using the metric system. We're using cubic meters. So it's that many kilograms in a cubic meter. So I've got to take, it says 1 cubic foot, so I've got to convert it to meters and cube it, because the volume of a cube, where the length is 0.3048 meters, is 0.3048 cubed. Because the base area would be squared and then the height would be 3 points. So let me explain why I cubed that. The volume of a cube is the side cube. That's sort of a shortcut. Because it's the base area is s squared, and then the height is s. And so when you find the volume, s squared times s is s cubed. So to find the volume of the cube, you need to take the side length in meters and cube it. So that is where I just felt like I needed to explain why I got that. Okay? So that's the explanation of why I got that. And I used the density formula, so that's how dense it is. And density is a weight, and that's why it's kilograms. All right. Moving on. You are building a cylinder parking tube. I did a terrible job at pronouncing that. You want the length to be 30 inches and the volume to be 589 inches cubed. What should the radius be? Whoa. All right. So we know the height, we know the volume, but we need to know the radius. And remember, the formula is V equals base area times height. But I also wanted to point out, let me just go back here, that formula can be switched to pi r squared times h. Now, so 589 equals 30, which is the height, that's our h, and then pi r squared. So, r squared, now, where did I get that number from? Well, I took 589 and I divided by 30 pi. When you plug that into your calculator, please, please, please put the 30 pi in parentheses because it's 30 times pi. So you either need to say 589 divided by 30, then divide that by pi, or put it in parentheses. Otherwise, you'll get the wrong value. Then you take the square root, boom, and there we got the radius, and it's that many inches. And radius is just a length, so it's not squared, nothing, it's just inches. Okay, hopefully you got that. All right, here we go. Example 6. You are building a 3-foot tall dresser. You want the volume to be 42 feet cubed. What should the area of the base be? Here, give a possible length and width. Okay, so first we got to find the area of the base. So we know the height. So we know the volume. So we plug it into the formula. Volume equals base times height, base area times height. So the base is 14 feet. Now, since we're not going to go decimals, and it's a rectangle, it's length times width. So possible numbers that multiply to 14 are 2 and 7, or 1 and 14. And we're not going to go into decimals. There are an infinite number of decimal possibilities. Okay. All right, moving along here. Similar solids. 2 solids of the same type with equal ratios of corresponding linear measures, such as heights or radii, are called similar solids. The ratio of the corresponding linear measures of 2 similar solids is called a scale factor. We talked about scale factors. So if the solids are similar, then you got a scale factor of k, And to get the ratio of their volumes, we've got to cube K. Ratio of areas is square. Ratio of perimeters is just K. Now we're introducing cubing it. So a square prism A and a square prism B are similar. So we've got two prisms that are similar. Each base of A is 4 inches and each base of B is 6 inches. The volume of B is 135 inches. Find the volume of A. So what we can do is we know that the scale factor is 4/6, which is 2/3. So all we need to do is cube the 2/3, just like it said in the previous, and then write a ratio. The volume of A is, we don't know, we called it V. And the volume of B, we know, is 135. And we just do our cross multiplying and dividing. And make sure, since we're finding volumes, you say inches cubed, please. All right, geometry students, I hope all is well. Please set up a Zoom session with us to help you guys on anything you need. I hope this chapter is going well. We all really miss being in the classroom with you. Take care. Have a good week. Thanks a lot.